Hi, welcome to Digital Electronics. Today I'm going to focus on subchapter 4 under the function of combinational logic circuit, decoder and encoder, multiplexer, demultiplexer, and also comparator. Decoder and encoder. Before we go very deep, we need to understand the concept of active high and also active low concept. So this active high, so the representative of active high is whenever the circuit have no bubbles. So when there is no bubble, such like this, we call it active high, and when there is a bubble, we call it active low. What is active low? Active low is going to be in active mode when there is an output of zero. So for the active high, it will be in active high or active high when the input or the bit is 1. We shall go to the decoder. Decoder is to detect a presence of certain specified combination of bits before present a specific output level accordingly. So only one output will be active at one particular time when there is a code. So it's something like when you have a, a when you have a particular message you want to send to a friend. So the message will be encrypted. So when you have a message if it encrypted, only a person who hold the key to the message can decrypt back the message. So similar to this situation, so only one will output will active when the code is present. So when you have an input of this one and you're going to have an output of this one. So first, for example, like this, you have a two possible of input A and input B. So A going to have a A0 or A1, or B B0 and B1, B bar or B, A bar or A. So there will be only four, because there is only two input, there will be four possibilities. Either you have 00, 01, 10, or 11. So the output over here is when you have a 00, the output 0 will be activated. When you have a 01, the output 1 will be activated. When you have an output 10, this particular output will be activated, and 11 you're going to have output of this. So this is a basic decoder for 3 bits. So because of it's a 3 bits, you're going to have a 8 particular response. So similar, so you have 000, so your first output 0 will be activated, 001. This particular, why this is 0 and this is 1? This is because the situation is this is in the form of active low. So when 000, this output 0 will be activated, others will be deactivated, or is not in active mode. So that's why you have a 0 over here, you have 1111. Similar to go to all the situation, 111, you're going to have the output 7 going to be activated. That's why you have a 0 over here, otherwise it's going to be 1. So this is an example of a decoder 74LS138. This is a 3 to 8 decoder. So you're going to have a similar situation like this. You're going to have a diagram of this. So this part will consider as input, your input, and this part will be your output type. So when you have a situation like this, you're going to always see the input over here. The input will be processed in a particular situation where you have A0, A1, and A2. This will have a two situation because this one is because of your particular is because of your and then you have going to have the negative and output. So this one is bar, so you're going to be another bar over here, so that's why it's going to be uh, input or output of 0 1 2 until 7. So 1 will be activated. So similar situation, when you have 0 0 0, your output 0 0 will be activated, this one will be activated. When you have 0 0 1, this will be activated, and so on. So when you have 1 1 1, this will be activated. So this is how you do for the decoder. So this one is for 5 to uh, 5 to 32 decoder. So you're going to have 5 input over here, so 5, and then you're going to process similar. So don't forget, you're going to have a enable such as this one. So you're going to have enable 1, enable 2, enable 3. So you're going to activate it using this particular uh, situation, six particular results, and the output will be from here, starting from 0, which is your first decoder output. So 7 is going to be continued 8 to 15, 16, 23, and last not but this is your 31st, which is your 32 result. So this is an example of your BCD 7 segment decoder. So you're going to have a diagram like this. So your LT is used for less lamp test. So when it's contact to 0, so this one is when it's contact to 0, it will be all the segment will be turned on, and you're going to have BI RBO as your input or output situation. So this one is your input, this one is your VCC, this one is your to activate the IC. So you're going to need the VCC, and also this is your output. So similar situation, only the diagram is looking quite different. So in a very short way, so you're going to have a BCD 7 segment decoder. Don't forget, your 7 segment decoder, you must have only 0 1 2 3 4 5 6 7 8 9. Next of the 9 is not valid, so not going to have that. So that's why when you have that's why you're going to have an input of A B C D. So your input A, B, C, D going inside, process over here, and output only one. In this situation, certain numbers can be activated at the same time. For example, to represent, let's say you have 0, 0, 0, 0. To represent 0, you must have a so you this one should be activated, 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 and not this. So that's why you're going to have situation like this. Let's say number 1 is activated 0, let's say this is 0 0 0 1. So you're going to have B is activated, C going to activate, so you're going to have B and C. Other than that, this one and this part, this part, and this part, and this part are not activated. So this one I'm using a, let's say I'm using a different color. So this one is 0, this one is not activated, this one is not activated, this one is not. So this particular side will be not activated except for the B and the C. So that's why you're going to have situation. Okay, now we're going for the encoder. Just now you already decode the situation, decode the code. Now we're going to encode. So that means you are doing the reverse now. So now for the encode, you need to, so you perform a reverse operation of decoder. So encoder will produce coded output. So just now is not coded, it's just directly your output, but now we're going to have a code. So yeah, so only one particular input were allowed at a certain particular time. So this situation, this just now we have a 3 to 8 decoder. Now we're going to have, so in this situation it's going to be 8, and this going to be 4. So you see over here is because it's a BCD decoder, so you need to have a 4. So you're going to have 1 2 3 4 5 6 7 8 and 9. So you're going to have, so let's see this please. So you're going to have a 9 situation over here, and then so because of this you need to know which one is going to be respond. Don't get messed up with your BCD segment. 7 segment is very special. So 7 segment is because these have a particular situation over here. So this is not similar to your 7 segment. So this is a very basic binary. So 0, you're going to have 0 0 0 0. 1 is 0 0 0 1. 2 is 0 0 1 0, and so on until you have 1 0 0 1. So I think this is already covered earlier, so you should already understood how you get this one. So for this situation you're going to have uh, so you're going to use this particular IC 74LS138, if I'm not mistaken. So you're going to have but your input will become, I mean your situation, the one you used earlier, you're going to be become, this is a very special IC, BCD, so it's 10 to 4 decoder encoder. So you're going to have 8 9 inputs, and you need 4 outputs. So here you need to, because we are going to use the don't care situation. Why we are using don't care situation is because we want to fast up the work. So if you see over here, first you will start from here to analyze. So you will go from here to here. So how you're going to do this is by so you're going to analyze from here to here. So first you analyze the number 9. So whenever you see, because this is an active low, so whenever you have a 0 over here, and automatically this is considered as this particular will be activated, and this particular code will be produced at the particular situation. So 0110 in a reverse way, because this is a bar, so should be, the output should be 1001, which is similar to the number 9 that we taught earlier. Okay, so let's say for the number let's say we go for the number 1. So because of number 1 is over here, so this will be activated. When this is activated, this particular code will be activated, which is 1110. And when we, because this is a reverse, is a bar, so it's become 0001 as your results. So let's go for the multiplexer. So multiplexer is known as a data selector. So you can use this as a data selector. So you need to, let's say you have a situation where you have a loss of inputs in, and then you can select which input I want. So let's say for this one you have this one, this one, this one, this one. This is a choices that you have, and using by this will control to select which one you want, and then you're going to have the output. So this particular multiplexer can be visualized using a vending machine. So let's say you have a vending machine, so you have a choices. So after you put the money, let's say you select this one, so you're going to have this particular as a product. So this is how the multiplexer will work. So we're going to, so don't forget, only one single exit will happen at any particular time. So the next one, this is the circuit. So this is your variable input. So you're going to have 0, 1, 2, 3, and this is your selector. So, and this is your output. So you have 0 0 0 1 1 0 and 1 1. So 0 0, you're going to select when you have a 0 0 over here. Let's say you have a 0 0. So this particular will be selected, and whatever data over here will be represented at the Z. So that's why you're going to have this particular response. So same goes to other. Let's say you have 1 and 0. So 1 and 0. So you're going to have a response of this one, and this one will be uh, a response of a Z. So this is for 8 to 1 or 16 to 1. So let's say you want to have a 8 to 1, so 8 input, and you want to select whichever you want, so you can use 8. This one is 8 to 1 mult, and this one is 16 to 1 mult. So 8 to 1 going to use uh, input of 8, and you're going to select using this particular selector, and you're going to have an output over here. For 16 to 1, the only modification you need to do is you need to select this one, enable, and this is enable. This will be your lower situation, and this one will be your higher. So you're going to have you need to activate this. So don't forget, you need to activate this using your S3. So this is will be your MSD, and this will be your LSB. So this one is going through over here to use to be used in your enable, and this one this is a active low, and this one you only need, okay, let's say this particular situation is when you have over here, this always going to be 0. So whenever you want to use higher number, you need to become 1. So when you have a 0 over here, it will be 1. So this will be not inactive. But when here is 0, sorry, when here is 1 and this will become 0, so this will be used. So this particular IC will be used instead of this one, and this one not will be in active mode. So that's why you have MSB of S3 over here. So you have selection of 1 0 1 2 until 7, and the next one is over here. So if you see over here, you see over here, this one is S0, S1, S2, and over here is also you're going to have S0, S1, and S2. So this one will be your select whether you're going to use is at is 8 or as a 16. So this is important. So this one is marks for logic function generator. So this is very simple, that's straightforward. So you're going to have a situation of an output over here, and this is your input, and this is your diagram. So if you see over here, this is a repeating of the similar before this. So this will be used as a response field data. So whatever is connected to the earth, this will be 0, and whatever is connected to VCC become 1. So this will become response of 1 1 1 1, and this will be and also 1, this will be 0 0 0. So if you see over here, you're going to have 0 1 1, this is 3 is 1, and you're going to 0 1 0 1. So this is how you draw for the situation for this particular input, and this is your code for your selector. So you're going to have S0, S1, S2. So you're going to have this one will be S0 1 and 2, So as usual, it started with 0, 0, 0, 0, 0, 0, 1, 1, 0. So you just follow the order until you get 1, 1, 1. So and this is your output. So whenever there is a, let's say the code now is 0, 1, 0. So you're going to have 0, 1, 0. So 0, 1, 0, the response of 0, 1, 0 is 1. So you're going to have, so you will be selecting the I2, this one, and then the output will be 1 at that particular moment. This is how it process. So now we go for the demultiplexer. Whenever you have a demultiplexer, uh, this is a reverse of operation of a multiplexer. So this one you can select which data or which situation you want. So this one you can see if you still remember, you're going to have if you have a fan. So at the bottom over there, there is a selector 1, 2, 3, 4, 5, which speed you want. So you can select. I need a very high speed. So let's say you set for number 5. So this one will change to, for example, to this part, and then your speed will be increasing to number 5. Your fan will be turning at a speed of 5. Let's say you don't want that. Let's say I feel very cold, I want to make it speed number 2. So you just select to number 2. So let's say you select number 2, you're going to have a response of this one particular response as your results. So this is how you can visualize how the demultiplexer is working. So you only can have you only need to select which data or which output you need to continue your data. So it's also another here another example is a photocopy machine. So you have a photocopy machine where you have a selector of lots of trays. So let's say you photocopy one a picture, and you will need to put it one set of pictures. So you need have in tray number 1, tray number 2, tray number 3, and tray number 4, so on. So it will be finish up the tray number 1, later number 2, later number 3, and so on until you finish. So similar concept. So I think the fan suits you much better. So this is how it looks for the 74LS, ALS 138. So it's a 128 the demultiplexer. So this will work as your selector. So always remember about your fan. So for your fan, you're going to have your dial over here, 1, 2, 3, 4, and then your selector, and then this is your fan. So this selector will be this one will work as your selector, and this is your data. So your data is the current that we connected. So and this is your output. So your output is the fan switching. So the fan switching will be your output. So this is how it works for this particular circuit. So we're going for the comparator. So the comparator concept is to compare two input at a particular time to check the equality of between the binary. So let's say you have an input A, input B, so you need to compare it. So there is a three possible that you can compare. So first you can compare whether A is smaller than the B, right? And second, you can compare B is smaller than A. And last, you also can compare whether it is A equals to B. So in this particular situation, this both smaller or bigger, it can be under one condition, condition 1, and also this will be your condition 2. So this can be done by using an XOR gate. So XOR gate, whenever you have a similar input 0 0, you're going to have a 0, or 1 1, you're going to have a 0. So this one, whenever the input is equal, the output is always 0. But when you have a 0 1 or 1 0, because it is not equal, your output is going to be 1. So this is also a simple process of a comparator. So this is a 4-bit equality comparator, so you can compare directly between A0 and B0. So you have an input, so you're going through here. So you're going to compare between these two. So whenever you compare between these two, similar situation as this one will be applied, and those you're going to have a result. If all the bits are equal, z equals to 0, else it become 1. So this is how it works. So a basic a comparator. So this is a to make it very easy. So you're going to have input. This is your input, and this is how where you process, and this one is your condition. So if you see over here, when A equals to B, your M will be activated. Where A is bigger than B, your N will be activated. And when your A is smaller than B, your P will be activated. So this is how this condition at particular situation for the input A0 and B0. So similar to this one, I would like to. So the situation over here is a comparator between two bits. So you have a bit 0 and you have a bit, sorry, A0 and B0. So you need to compare between this input and also this input. So like I mentioned, so this is the condition and how it looks. So this is in a time diagram. So in a time diagram, so we can see how it looks. So you're going to compare between two bits. So you have a bit A0 over here and also B0 over here. So now is 0 0, and then for the first one, nothing much of change in M and B. So for this one, I strongly suggest you to go one by one so that it's much easier at the beginning. So let's go for the output M first. So the condition for output M is equals to, you need to have A equals to B. So you just compare between A and B. So A0 and B0. So over here, this is this is 0 0, so you have 0. This one is 1, this is 1, this is 0. So you have 1 and 0. When you compare, is it equal? No. So that's why you're going to have a 0 over here. This one is 0 1, so you're going to have a 0 1. It's not equal, so you have 0. 0 1, you're going to have 0. Okay, for this one you have 1 1, so 1 1 is equal, so that's why you have a 1 over here. And this is 1 0, so you're going to have 0. 0 1, you have a 0, and 1 1, you have a 1. So let's say we go for the M. N is equals to A is bigger than B. So whenever the situation A is bigger than B, N will be activated. So you have over here 0 0. So just have a 0 over here, no problem. So 1 0. So is A is bigger than B? Yes. A, because A is 1, B is 0. So that's why A is bigger than B. So this is become 1. And this one is 0 1, so A is bigger than B? No. So that's why you have 0 0 0, 0 1, you still have 0 1 1. Okay, this is very important. A is 1, and B is 1. So 1, 1. Is it A is bigger than B? No. That's why it become 0. 1, 0 is 1, 0, 1 is 0, and 1, 1 is also 0. So similar situation to this. These two are similar. And for P equals to A is smaller than B. So over here, this is 0 as usual. A smaller than B. So is this A is smaller than B? No. 0, 1? Yes. 0, 1? Yes. 1, 1? No. 1, 0? No. 0, 1? Yes. 0, 1, 1? 0. So that's why you have a situation of a time diagram like this. Uh, Next, we go for the basic two magnitude. So you're going to have a bigger or complex situation. So A0, A1, B1, and B0. So you're going to compare between. So when you compare situation like this, you always compare this and this. So B0 always compare with A0 and B1 compare with A1. Don't mess it up or don't change it. So you always compare in a sequence like that. So it's always like this. This is A0, A1, B1, B0. This one is B1, this one is A1. So you always compare directly like this. So when you have a 0, 0, you have a 0, 0 and 0, you're going to have a M is activated, N and P is 0, 0. So you need to go back to your time diagram to check one by one. And this is the output for this particular situation. And when you see over here, this is after you done if you done this one, this one, this one, and this one, this particular will provide you with this Boolean expression, and will provide you this Boolean expression. P will be providing you this situation. So please always check your chapter 3 for you to know how you get this particular, and from here you just draw your circuit to become this. So, so this one is much higher. You're going to have a 4-bit magnitude comparator. So when you have a situation like this, you don't forget always compare a situation. This compare with this one, this compare with this one, this compare with this one, and this compare with this one. So and then later you're going to have the results of this one. So this is how it looks under the circuit. So this is how do you arrange, and you're using lower order comparator and higher order comparator. So then you're going to have this result. So please continue to document 4.8 for further on. Thank you.